Hi there, thanks for joining us. This is Space Nuts, where we talk astronomy, space science, and pineapple shirts. My name is Andrew Dunkley, your host. Coming up on this episode, more news on moon water, or lunar H2O, or whatever you want to call it. They've found some, and it's a bit strange. We'll also be revisiting an old friend, Oumuamua, the space doogie. They've come up with a new theory, or maybe some new science as to why it did what it did when it passed by a few years ago now. We will also be answering questions on the DART mission, rogue planets passing Earth, and asteroids hitting us. People are seemingly intrigued by all these what-ifs, and I am too. We'll answer them all and give you plenty of information on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Joining me, as always, is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you today?
I am quite well. Do you like my shirt?
Yeah, the pineapples are below the limit of resolution on my screen. And they actually... they still look like insects, I'm afraid.
Oh,
they just look like
they probably are.
It's crawling all over you.
Now that you mention it, they just look like black and white ladybugs.
Yeah. There you go. So, because I don't have a pineapple shirt. Changing topic, wasn't it nice to see Space Nuts coming fifth in the top 20 space podcasts a week or so ago?
Of all time? No, I don't know. But we got a really great review, and they ranked us number 5 in astronomy and space science, or science in general, I think it was, podcasts. And they said some really nice things about it. So they obviously only listened for a couple of minutes. But
that's right. It must have been a good couple of minutes, really.
Yes. No, it's really, really good. It's nice to get some feedback, especially from people who are influential. Yes. It's nice to be sort of up there in the rankings. So that's terrific. Very, very pleased with that. And hopefully we can keep it going. It's only taken us 20,000 years to get here. So
it did comment not only on the erudite presenters that this podcast has. What universe do they live in? Anyway, not only on the erudite presenters, but also on the production. What a great production it is. And that might have something to do with that guy who you always say never does anything.
Hugh?
Yes.
Hugh? Yeah, he does work very hard, and I do give him a bit of stick. But, he was my boss for many years, so now it's payback time.
I didn't know that.
Yes, he was. Yes.
Well, that explains a lot.
As you go through life, things change. So he was my boss. When I've got time, I'll tell you a really great story about him that dates back to when I was a kid and doing job experience.
Right.
Because it was the last thing I ever told him before I left the ABC, and he had no idea. But it's a great story. So please remind me to tell that one day, because it's quite a long story.
Right.
But it's funny how things happen in life. So Hugh used to be my boss. But I used to be the boss of the now state member for Dubbo.
Oh, that's remarkable. Right.
Yes.
Yeah.
So he's now an MP, but I used to be his boss. That's my claim to fame.
Very good, yes.
So I taught him everything he knows. Although after last weekend, he's now in opposition.
Yes, there you go.
Not astronomically speaking.
No. He's on the other side of this.
He's on the other side of the
sun.
Yes, exactly. All right, let's get down to business, Fred, because we've got a bit to get through, and this story about water on the moon is quite intriguing. What's going on?
It is, and it's. I mean, you and I talked about water on the moon before, particularly about the fact that several spacecraft have detected what looks like sheets of ice, effectively, in the deep craters near the moon's south pole. And that's one reason why the Artemis mission is targeting the moon's south polar region for its first human crewed landing in from 2-3 years, something like that, maybe a little bit more. So because that seems to be just ice that has formed there, probably through maybe comet impacts billions of years ago. But it's easy to get your head around that there might be ice, even if it may be, that the lunar soil particles have got coatings of ice on them. That's something we can understand. But the latest discovery is a little bit more counterintuitive than that. And it comes from the Chang'e 5 space mission, the China National Space Administration, which in 2020, I think it's towards the end of 2020, returned soil samples from the moon, which were selected from the Chang'e 5 landing site, which was in Oceanus Procellarum, the ocean of storms, the biggest of the basalt lava fields that there is on the moon. From our perspective here in Australia, when you look at the moon, it's in the lower right hand end. It's the upper left end when you're looking from the northern hemisphere. It's the biggest of the grey patches, the ocean of storms. So that was the landing site, and it's the first time we've had samples returned to Earth from that site. None of the Apollo astronauts landed in the ocean of storms. It's a good place to stay away from if it's stormy.
Yeah, sounds like it.
Yeah. So what we've got is these several grams, I think, of lunar material were returned by Chang'e 5, and there's now some really quite remarkable results come from them because they contain glass beads. Now, these glass beads are somewhere between well under a millimeter in diameter, a small fraction of a millimeter, perhaps human hair size. I'm not sure of the size of human hair because I don't have much. But range up to, I think, a little bit under a centimeter. So okay. They're not microscopic. They're things you can see if you have them in your hand. But they have been investigated, and they contain water molecules within the glass bead. There are water molecules there. And so the interest is, how did they get there?
Yeah.
And the story is that, first of all, where did the glass beads come from? And these are thought to be beads that are created when micrometeorites hit the surface of the moon. These are, probably just things the size of a coin or something like that, or a small stone. Hit the moon's surface and they hit it at maybe 30, 40 kilometers per second because there's no atmosphere to slow them down. And the energy of that impact actually throws up some of the lunar surface, basically explodes, heats it to a very high temperature very briefly, and you get glass forming because rock is silica and glass is silica as well. It's just a different form of it. Now, the interesting aspect is that these are different beads from what the Apollo astronauts found in their investigation. So the Apollo landing sites were all in the smaller Maria. Maria is just the posh word for seas on the moon. It's the old term for what these grey areas were. And the glass beads that were found in the Apollo soil samples seem to be mostly caused by volcanic phenomena. So we've on Earth we see volcanic glass. It's rock that's been heated so hot that it turns into glass, and that's commonly found around volcanoes, as you might expect.
Yes.
But that is different in its structure from beads that are heated by micrometeorites. I'm not sure what the differences are. I suspect it's to do with the speed with which the thing is heated to its high temperature. I've seen pictures of these glass beads from the Chang'e sample compared with the glass beads from the Apollo samples, and the most obvious difference is that the Apollo beads are green and the Chang'e beads are black. So there's an obvious difference there that might not have anything to do with their origin, but that differentiates them, at least at some level. Anyway, to cut to the story. So
yes,
the question is, how did the water molecules get inside the glass beads? And the theory that has been developed by a large group of scientists, including many scientists from China, but it's an international group as well. They believe that what happens is that of course, the lunar surface is bathed in the solar wind, the wind of subatomic particles that comes from the sun, which we are largely shielded from by the atmosphere, that hits full force on the surface of the moon. Now, most of that solar wind is hydrogen nuclei, it's protons. Right. And so what you've got is basically hydrogen constantly flowing onto the surface of the moon. And hydrogen is, being the lightest element, it's also the one that can creep into structures most easily. In fact, you probably know that, one of the problems with a hydrogen balloon is it leaks because the hydrogen just finds its way out, being the lightest element. Well, the converse is the case with these beads. The hydrogen has leached its way into the glass beads. The glass is essentially porous on the scale of hydrogen atoms. So hydrogen comes from the sun, gets into the beads, and it finds oxygen in there. And so you've got a reaction that takes place within the bead, and you've got a water molecule being formed. And so that's the theory behind why these beads are so rich in water molecules. And it turns out that there's probably millions, if not billions, of tons of this stuff on the moon, which is exciting people as being a possible source of water for future lunar explorers. And the interesting thing about this is that it's not just near the South Pole, it's kind of everywhere on the moon's surface. And so in fact, it may even be as simple as just heating these things up till they melt, and then collecting the vapor that comes off and condensing out the water that comes from it. It might be a bit more complicated than that. But
so are they saying that this is water that's been created due to an interaction between hydrogen and the glass beads, rather than water that was already existent? That's right.
Now, that might be there too. Because we think some of the Earth's water was actually, it came from the rocks themselves, which were when the Earth was being formed by pre-existing water molecules. Water in space is very, very common. It's in fact the most common two-element molecule in the universe.
How about that?
The most common single-element molecule is molecular hydrogen, because hydrogen's the commonest element by far. But if you're having two elements together, then water is the commonest of all of them. So really, really interesting finding that might one day have quite significant implications for the human exploration of the moon. Because water not only provides something to drink, it's also rocket fuel.
Exactly.
When you separate it.
And I know you said that's why they've chosen the South Pole as a landing zone. I think there's another reason, actually, because they won't have to look up to see Earth. They can just look straight ahead. Is that right?
Yeah. It could be. You don't have to look up. You crick your neck.
No, exactly.
Yeah.
That was a chiropractor's idea, actually. I also wondered, as you were talking, something crossed my mind, because you were explaining how, depending on where you are on the planet, where this particular zone was from an observer's point of view. I was just wondering, if you were looking at the moon, constantly looking at the moon, and you were flying in a plane and you're moving from the southern hemisphere to the northern hemisphere, how would the moon change? I mean, if it changes perspectives depending on where you're standing, what would happen if you crossed the equator in a plane while you were looking at the moon?
It passes over your head. It goes overhead and ends up the other way up.
Is that right?
Yeah.
Would it like an instantaneous effect?
No, it's just gradual. Supposing you were on a plane flying from the North Pole to the South Pole, and the moon was in front of you when you left, it'd be behind you when you got there, and it'd be the other way up.
Yeah, I just wondered how you would notice the change, but it would just be a gradual rotation,
yes, that's
I
right.
suppose.
Yeah, and it will essentially pass over your head. I've probably told you this before, Andrew, but there's exactly this thing. gave me one of my worst moments in astronomy.
Oh.
Because back in June 1978, I was making my first visit from Scotland, where I lived, to Australia, and I had time awarded to me on the Anglo-Australian telescope, and it was going to be dark time when the moon was new, so essentially not in the sky. That was because the objects I was trying to observe were very faint, and it would have been absolutely useless trying to observe them when the moon was above the horizon. So it was new moon time. I did all my calculations, got the right dates and everything, got on a plane, headed down to Australia. So the last leg of the journey was down coming into Sydney, and I was on the must have been on the eastern side of the plane. Looked out the window, and there's the moon, and it looked to me as if it was at first quarter. Well, first quarter is a week away from full moon, but of course it's upside down, so it's actually last quarter, which is a week away from new moon. But it absolutely freaked me out. I thought, I've done it all wrong. I've calculated everything wrong. It's going to be full next week when I've got time on my telescope, and I won't see a thing. And I calm yourself, Fred. Calm yourself. Just think about this. The moon is upside down from the southern hemisphere, so first quarter looks like last quarter. But it really did freak me out for a matter of minutes until I calmed down and worked out what was happening. Oh yes, I'm on the other side of the world.
No, I can understand that. You duped yourself. I remember coming into Sydney one morning as the sun was rising, and I couldn't figure out why I could see the sunrise to the left of the plane and not the right. I thought, hang on a minute, there's something weird going on here. They realised we weren't flying east. You don't fly east out from the United States to Australia. You fly, west. You fly southwest. Yes. So naturally the sunrise is going to be to your left. But I couldn't figure it out. I'm sitting there, I'm jet lagged to hell, but I'm trying to figure it out. My brain wouldn't process the information properly.
I think that was my problem as well. It's my first experience of serious jet lag.
Yeah, it was. It can really affect you. It's a bizarre thing. All right. Maybe another source of water on the moon in those beads. Fascinating. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, to an old friend, we've spoken about Oumuamua many times. Now, this is an object that passed through our solar system, passed reasonably close to the inner planets, and then passed by the sun. It did so in an unusual way. It changed direction. And of course, that got a lot of people saying, oh, it must be a spaceship. But it was also known to be an extrasolar asteroid. It was not of this solar system. It's come from somewhere else. But now there's some more information that it might explain why it did what it did.
Yeah, that's right. So it's such an interesting object. And you always call it the space doogie. I don't know why. I used to call it the breadstick or something, or cigar or something.
Didn't it turn out to be a pancake or something? Yes,
that's right. It's most likely to be an object 115 by 111 meters across and about 19 meters thick. So it's a sort of roughly pancake-shaped object. And that the problem is the only thing you've got to go by is the light curve, the way this object, which is tumbling through space, is probably the right word. It's bright as the sunlight changes. How much of its surface you see, its brightness varies actually by a factor of 12. It's huge. It's an enormous factor, and that tells you it is a funny shape. It was, as we said, first of all thought to be the shape of a breadstick, but now is more like a pancake. And that actually gave, I'll postpone that comment. Let me first of all mention that the way scientists knew that it was an interstellar traveller was the speed that it came into the solar system. It was first observed actually on the 19th of October 2017, so it's getting on for 6 years ago.
Wow.
And it was from Haleakala, the summit of Haleakala, the extinct volcano on the island of Maui, where the Pan-STARRS 1 telescope is operated, and that's why it got a Hawaiian name, Oumuamua, meaning first messenger from afar, which is what it is. And its speed, 87 kilometers per second, was what gave it away as coming from outside, because things don't travel at that speed that originate within the solar system, even from the Oort cloud, which is on the very edge of the solar system. So that's all fine. It was observed by as many telescopes as humankind could get on it. But what was the mystery was that its orbit did not behave as you would expect if the only forces on it were the only force on it was gravity. So it had what are called non-gravitational perturbations. Its orbit was being changed by some non-gravitational effect, and it was more than just the straightforward pressure of the solar wind on it, which is actually one of the things that changes comets' orbits. So that caused the mystery, and yes, you're right. Avi Loeb of the Harvard Institute for Astrophysics, I think he still thinks it's an alien spaceship that was actually using its thrusters to change its orbit. A very distinguished scientist, but always very controversial and very provocative in what he says. But the more sober fraternity of the astronomical community has been looking for mechanisms by which it might be changing its orbit. And one of the theories was, and I think we've talked about this, was that when it was established that it was a pancake shaped, it was thought to be possibly a sort of shard of material that had been shaved off an object like Pluto. A dwarf planet in some distant solar system that had a collision with something else. Lots of fragments came off, and something the shape of a pancake flew through space. Now, its color was quite reddish, and parts of Pluto are reddish, and that's thought to be due to solid nitrogen having been bombarded by billions of years of solar cosmic rays, the subatomic particles that come from the universe in general, rather than from the sun, turning it red. That's a known process, and so there was a suggestion some time ago that it was a solid chunk of nitrogen that was outgassing, and it was when the nitrogen got illuminated by the sun or heated by the sun, it was outgassing, and that was providing a thrust. But that sort of didn't work. It seemed to it seemed to be a long stretch of the imagination as to how something like a solid body of nitrogen, and actually molecular hydrogen was suggested as well, as being the same sort of thing. How could that survive? So the latest theory, it's actually in some ways similar to what we've just been talking about regarding the moon, is the way the way subatomic particles behave in space. So you've got this thing that may well be made mostly of water, because that would be the most likely thing, that it's an iceberg, a bit like a comet would be in our own solar system. But the thinking is, and this work has come from it's California, University of California, Berkeley. And somebody at Cornell University. These are two scientists who've basically put a different mechanism as the possible culprit. What they're suggesting is that if you've got just a bog standard icy comet-like object, it's constantly being bombarded by the cosmic rays that I just mentioned from the universe, and it turns out that the effect of these cosmic rays is to penetrate the ice and essentially create hydrogen atoms. So you get basically build-up of hydrogen gas deep under the surface, because it's the cosmic rays are, they can go a long way into the ice. And the suggestion now is that those reservoirs of hydrogen within the body itself, as it got near the sun heated the surface, the ice sort of melted a bit and let the hydrogen out. on the side of the object that was most facing the sun, because it's tumbling, so it's not simply a one side that's facing the sun, and the calculations show that would produce enough thrust to give you exactly the changes in the orbit that have been suggested. It's a long. It's actually once again this comes from phys.org, one of our favourite websites, which is titled "A Surprisingly Simple Explanation for Oumuamua's Weird Orbit." I don't think it's that simple, but it does tell you in detail in that article, and you can look at the original paper as well. What the conclusion is, that it's that it is essentially a fairly standard object, but having had probably billions of years in the full glare of cosmic rays without a magnetic field to change them, which we have in the solar system, that might very well be why that is the outgassing, or causing the outgassing, that's given rise to the comet, to the orbit changes.
Yes, it also changed speed, didn't it?
Yes, that's right. It did. Well, it would have to. If its orbit alters, it changes its speed as well. Yeah. So yes, and in fact, it is a change of speed, because what changes an orbit is an acceleration, and that's what. Well, you would know that is a change of speed.
Indeed. It's not the only one, of course. We had Borisov as well.
Yeah.
Did it change direction and speed too? Or?
Yes, but Borisov. So I've kind of missed the fundamental problem with Oumuamua, which was that there was absolutely no visible tail or coma or any of the things that you normally associate with this kind of activity. You would expect to see that gas radiating in some way, i.e. being bright in telescopes. And that didn't happen with Oumuamua, but it did with Borisov. Borisov was much more like a typical comet. It was very... its behaviour was quite standard, even though it was known, again, by its velocity to have come from outside the solar system. It behaved like a comet within the solar system. Oumuamua didn't. It showed no sign of any kind of outgassing at all, yet its orbit changed, so something was happening.
Okay. And they were both going too fast to be captured, weren't they?
Yes, that's right.
They're on their way somewhere else. I was just thinking also about Oumuamua. If it was part of an obliterated dwarf planet, I guess there's a probability that other parts of that doomed planet are flying off in all sorts of directions in the universe.
Yes, that's right. And depending on how far away it was, it could be millions or billions of light years away, the parent body. So they could be going in, the likelihood of finding two of them coming together in the solar system is very low. I think even if they set off in the same direction, just, a degree or two difference in their directions, by the time you get to the solar system a billion light years away or a million light years away, those two objects are
squillions of kilometres apart.
That's exactly right, yeah. So sorry, just to wrap up though, the thinking now is that this is that Oumuamua is more likely to be something like a comet rather than like a chunk of a dwarf planet that's been broken off.
Okay.
Yeah.
Very good. All right. I guess we'll probably get more news on it. I know they're still analysing the data, but and there was a talk of chasing it at some stage, but it's moving so fast, and gosh, it'd be a long, long way away already. So I think we should probably put that idea to bed. But there was a lot of data captured, and they'll continue to analyse it, I'm sure.
I think we covered this story that it might have been Elon Musk and SpaceX, but the idea was to send a spacecraft to rendezvous with it. And I think the earliest it was going to get there was 2050 or something. It was going to be long, long down the track.
Indeed, it would be. Yeah. All right. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, it's time to deal with some audience questions. I thought we'd tackle a few text questions today because we tend to lean more towards the audio. And a couple of questions we've got are of a similar ilk, but we'll get to them in a minute. This first one comes from John in Dayton, Ohio, I assume, in the United States. He said, I was looking at the images after the DART mission impact, and I was intrigued by the streamers that appeared to be emanating from Dimorphos. Is it possible that these were chunks of ice that explosively sublimated after being exposed to the heat of impact? Could that also have provided an additional shove that affected the orbit even more than we had originally estimated? If so, do you think they'll consider different methods of deflection for different types of asteroids, as in rubble piles versus solid rock, etc.? Thank you both for a wonderful show. You're lovely people, and you're the bright spot of my week. Take care. Oh, that's nice. Thank you, John. That's really lovely. Appreciate those comments. The DART mission, they're continuing to analyse the data, but it's proved to be incredibly successful. The orbit change was more than they expected. He brings up an interesting point.
Yeah. So I think, in fact, we've, within the last week, got new images from the European Southern Observatory's telescopes of the aftermath of the impact, which I have to confess I haven't had time to look at. It's been a very busy week. But effectively, what John's saying is absolutely right. The impact itself basically caused an explosion because it's hitting a solid-ish surface. Might be a bit of a rubble pile, but it was still fairly solid. And just that half ton of material hitting it at 6 kilometers per second causes a huge generation of heat, and lots of stuff vaporized. And then I assume that what we're seeing with those streamers, and John's exactly right, there's some really quite spectacular straight lines of stuff, and they're straight because everything travels in a straight line in space. Yep. In the sense that you don't have winds blowing it around and things of that sort. So that is, I think, probably the dusty debris. So it may be stuff that's recondensed. I should have got my head around the physics of all this. But basically, what you're seeing is the debris cloud that came from that. And John's absolutely right. The explosive effect of the impact, the energy that was generated, the explosive energy, did add to the change of Dimorphos's orbit. And I think it was, if I'm trying to remember the numbers, we did look at this, that just a straightforward clout by a heavy object, yes, that will move the orbit slightly, but because of the explosive effect, if I remember rightly, it was between 2 and 5 times more thrust than you would just get from the simple kinetic impact, hitting something and it moving away. What you get is an additional explosive effect that actually vastly magnifies the effect of the collision. So, and that has been very, very encouraging to all of the mission scientists. So DART, yes, a success story, which is still being told, I think, as John's question actually confirms.
Yeah, and he does suggest maybe different methodology for different types of targets, and that's probably a logical thing to consider.
Yep, absolutely.
But I suppose the way we deal with a future threat is going to be based on how big it is, what it's made up of, and how much time we've got.
Yes, it's all about time. That's right.
So they'll be the various elements.
And just to draw the line under it, there's nothing bigger than 140 meters, I think. Nothing known yet with a probability of impact within the next century.
And remind us again what a 100-meter object would do if we had a direct hit.
I'm glad you asked me that. Well, a 100-meter object is it's absolutely deadly over areas the size of states, maybe even continent-sized. So you've got a 1 to 2 kilometer crater, and mass casualties. And we think there are about 25,000 of these, of which we think something like 40% have been discovered so far. That is what the whole asteroid search program is working on at the moment, objects in the 140 meter class, thereabouts.
We've had a few pass close to Earth in recent times.
That's right. Yeah.
In the last month or two, one of them actually passing between the Earth and the Moon. Of course, the popular press go with the doomsday headline, but we've always known that they're not going to hit us. It's the ones we don't know about that we need to find.
Exactly. And that's why, there are moves afoot to put a spacecraft inside the Earth's orbit, looking at the Earth with the sun behind, so you pick up things that would look as though they were coming out of the sun from our perspective. And that, because they're the ones that you miss, it's just like the old World War II. They came at me out of the sun. It's the same sort of thing. But that project, I think we talked about it briefly a few weeks ago. 2028, I think, is where it's been pushed back to. May even be further than that. We need it now, really.
Yeah, we do. We do really need it now, but we'll get there soon enough. Hopefully it won't be too late. Oops. Thank you, John. Now, I've got a couple of questions that are, they're of a similar ilk. These next two kind of relate to each other. This comes from Patrick in Northern Ireland. Hi, Patrick. Nice to hear from you. If a rogue planet, say Mars-sized, entered the solar system on the right trajectory and passed between the Earth and the Moon, what would happen? Tides, earthquakes, orbital changes? Love the show, guys, but you don't sound like you would. You don't sound like what you look like. I had you 30 years younger. The joy of radio.
That's right. Radio's brilliant. Exactly.
Yeah, I've got a face for radio.
I'm glad he didn't say 50 years younger, which would probably be more appropriate.
Yes.
Anyway.
Yeah, well, that would be worse. That'll have a couple of weeks away from that. Thank you, Patrick. Really nice of you. Anyway, carry on. If a rogue planet size of Mars entered the solar system and passed between the Earth and the Moon, what would happen? Do we want to know?
Yeah, it would be. It would be the end of everything, really.
There you go.
Yeah, there's something,
including Patrick.
Yes, that's right. Yes, and that lovely part of the country, Northern Ireland. It's a beautiful spot.
Haven't been there yet.
You should go. And
I will.
Yes.
And I'll find Patrick.
Well, you might. Yeah.
I'll find plenty of Patricks. It's just finding the right one.
Yeah. It's just the gravitational disturbance will be colossal. In fact, I don't even know whether if the object was moving fast enough, maybe it could go between the Earth and the Moon without colliding with one of them. Yeah. But there will be such enormous tidal effects. It would. I would guess it would risk the integrity of the Earth's crust. It would make tectonic movement look pretty leisurely. I think with something of that size,
So a non-survivable event, I imagine.
Absolutely, yeah. Yeah.
Don't need that. Any rogue planets in the vicinity that you know of?
Well, no, that's the thing. The good thing about planets is they're big and they're easy to find.
Except for Planet 9. Can't find that.
Well, that's a very good point, yes. Yeah, thank you. That's just totally demolished my argument there.
But it's not close.
The good thing is Planet 9's not on its way. If it was anywhere, if it was anywhere within the inner solar system, the part of the solar system where it could do any damage, we'd know about it.
Yes, indeed. So thanks for the question, Patrick. Nobody really wanted to know, but now we do. But we'd certainly be able to spot one a long way off, but I don't think we could do much about it if it was headed our way.
No, that's right. Yeah.
Even a DART sort of mission would probably not be at all effective.
You did right there.
Yes. But hopefully there aren't too many rogue planets in the vicinity. Thank you, Patrick. Let's move on to our final question. This one comes from Javier in Puerto Rico. I don't think we've had a question from Puerto Rico before. Hello, guys. In a previous episode, someone asked about an object big enough to change the orbit of the Earth, and the professor said it would be easier to change its rotation. My question is, if an asteroid impacted the Earth and increased the speed at which it rotates on its axis, would the orbit increase as a result of the additional angular momentum in time? Also, would it maintain the new rotational speed, or would it eventually return to its normal speed? Thank you for the show. Big fan. Thank you, Javier. Javier.
Yeah.
That's look. We get a lot of questions like this, but I always enjoy them.
I do too.
Even Patrick's.
So the answer, Xavier, is to the last bit is that it would, unless there was another perturbation, it would stay. The new rotation would basically stay permanently, because you've added angular momentum. But even a Mars-sized object hitting the Earth, which is how we think the Moon was formed, would certainly have changed the rotation. But actually, something that size would have changed the orbit too. It's just an enormous impact. Something the size of an asteroid wouldn't, though. And you're right about the angular momentum, but that would not be transferred externally to the Earth's orbit. It would be perhaps an increase or decrease in rotation. We think that's possibly happened already with the Chicxulub event.
Yeah.
That there would have been a very slight change in the Earth's rotation, as well as a slight change in where the pole of the Earth was. But you're talking about microseconds and centimeters almost on the surface of the Earth. So it's not a large effect, even for a 15-kilometer sized body, which the Chicxulub asteroid probably was. But once again, the Earth's orbit would largely remain unchanged.
Yeah, I was just trying to look up the Chicxulub event because I couldn't remember what year it was. But the funny thing is, with the Google search I just did, as I'm looking through the list of websites that feature the Chicxulub impact, Google's very cleverly just had an asteroid pass across my screen.
Yeah.
I didn't.
Yeah.
I'm going to refresh that and do it again because it's very funny.
I think I've seen
there
that.
It is.
Yeah. I think there was something similar.
And then the screen shakes when it hits the bottom of the screen.
Yeah.
I've never seen that before. That's hilarious.
The clever one, I can't remember what it was, but something similar to that. I was Googling something last week, and something came in from the side and hit it, and the whole page was tilted over. I don't know how you do that. The whole text of the Google page was actually on a tilt.
Aren't they clever? Aren't they getting clever? I just love little things like that. I'm easily pleased.
Yeah,
but I'm just. What year was it again? 19.
That's the Tunguska event you're talking about.
Oh, of course, yeah.
Yes, which was 1908.
Of course, yeah. Chicxulub. Yeah, I'm getting them mixed up.
Chicxulub was 15th of February, 66 million years ago.
Yeah, that's right. Of course. Oh dear. And
of course was not far from Puerto Rico, where Xavier is from.
Yeah, absolutely. So the answer is we probably wouldn't change orbit, but the rotation might change with an asteroid.
It is. To change the orbit, you need an external force, something that's really hitting it hard.
Yeah,
it's a hard thing to change.
Okay. Thanks, Javier. Great question. Really enjoyed that one. And thanks to Patrick and John for sending in their questions as well. And don't forget, you can send a question in to us if you would like us to try and tackle it. Just jump on our website, spacenutspodcast.com or spacenuts.io. There's an AMA link at the top. You click on that. You can send us text or audio questions, or on the right-hand side, just click on send us your voice message. If you've got a device with a microphone, that's all we need. Don't forget to tell us who you are and where you're from, because we love to know, and we love to hear your voices, but we like your text questions as well. And plenty more on the website to check out also. And a special thanks to our patrons, the people who voluntarily put a little bit of money into the kitty every week to keep the lights on. That is fantastic. We really appreciate that. Fred, we're done for another day. Thank you so much, sir.
It's a pleasure, Andrew. Anytime. In fact, probably quite soon.
Yeah, very, very possible indeed. Very possible. Fred Watson, astronomer at large, joining us on Space Nuts every week to talk the talk. And the man who walks the walk is Hugh back in the studio. Well, he actually does a lot of sitting, lounging and coffee drinking, but he also pushes buttons occasionally. Thank you, Hugh. And from me, Andrew Dunkley, thanks for listening. We'll catch you on the very, very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.